Hello everyone, welcome to another video of General Science of Class 10, and today we're going to talk about refraction of light. Yes, so we have done about reflection, now we are doing refraction of light. And what does this mean? Refraction of light means the bending of light. So when light bends because it encounters a different type of media. Now what is a medium? Suppose this air I am around right now, this is a medium. You move into water is another type of medium. You move into some sort of oil like kerosene, that is another medium. You go out of air into the space, you have vacuum is another type of medium. Okay, so we have different types of medium, and every type of medium has different types of densities. So whenever there is a change in density between mediums, that's when refraction of light occurs. So to put it in a very simple way, I think most of you may have observed this. Suppose you have a bucket of water, and you have water here, and you place one stick, say for example, into the bucket. Okay, now when you look from the top, if you see from the top, what do you see? We observe, what is observed is this stick seems to be it, this part remains the same, but this part seems to have moved up a little bit, right? It does not look like a straight stick. It looks like the stick has come here and it has moved up, just elevated a bit. Why does this elevation occur? This is because of refraction of light. Here the light rays are not coming directly into your eyes in a straight line. Whenever light encounters a different medium, it bends. Okay, and we are going to see why this happens, how these things work actually in refraction of light. So before we move into this, let us just draw a simple diagram to understand how refraction occurs. Suppose this is, there are two medium, this is medium 1 and this is medium 2. Okay, both of them have different densities. Now if you have a ray of light coming in from medium 1 and hitting medium 2, okay, in this point, the boundary between the two medium, what is expected means, suppose if there is no refraction, what will happen? The light will move directly like this in the same direction, it will move in this direction. But because of refraction, what happens? It will change its direction. It will not go in this direction, rather it will either move in this direction or in this direction, depending upon the density of the medium. Now what will happen, that we will see. So either it will go in this direction or it will move away from the normal. So here if we draw a perpendicular, this perpendicular we write as n means normal. Normal, normal means the perpendicular at the point of incidence, means wherever the incident ray hits, at this point if we draw a perpendicular, it is called the normal. Okay, so what actually, why have we drawn this diagram? In order to understand the two laws of refraction. We have seen the laws of refraction laws are also pretty much similar. The first one is similar, the second one is different. Okay, so what do we have here? The first law states that the incident ray, this is our incident ray, the incident ray, the refracted ray and the normal all lie on the same plane at the point of interface of the two medium. All lie on the same plane at the point on the interface of the two medium. That means in the boundary of the two medium, medium 1 and medium 2, the incident ray, this ray, the refracted ray, the one that after refraction moves, and the normal all lie on the same plane at this point of interface. Okay, the incident ray, the refracted ray, the normal all lie on the same plane at the point of incidence, the point of incidence. Okay, this is similar to that of reflection. Okay, now what is the second law of this laws of refraction? The second law states, right, that is a new one, and we are going to see a new name for this law as well. Okay, so let us erase a bit of it, a bit of this stuff. Okay, so we have these things here. So now yeah, so let's now draw the normal once again. Let us use the scale, it will be easier for us to draw. Okay, so if we draw a normal here, means a perpendicular, then the angle made by the incident ray with the normal is called the angle of incidence, it is I. And here is our, this is our incident ray, and this is our refracted ray. So the angle made by the refracted ray with the normal is called the angle of refraction. Okay. Now we are going to use a bit of trigonometry here. The second law states that if you find the ratio of the sine of the angle of incidence to the sine of the angle of refraction, that means sine of incidence by sine of refraction, this will always be a constant value, always a constant value for a given pair of medium. Suppose between air and water, as I have shown you in the bucket, you are in the air, the stick goes inside into the water. So the interface is between air and water, air on top, water at the bottom. So there must be an angle of incidence for the ray of light. When the light enters through the water, there must be a ray of the angle of refraction as well, just as it happens in this case. There must be an angle of incidence, there must be an angle of refraction. Now if you find the sine of those angles, these are trigonometric ratios. Sine is a trigonometric ratio. So sine I and its ratio to sine R, that value for air and water will always be constant. Now if you change the medium, suppose you change water with replace water with oil, suppose mustard oil. Now the refractive, this value sine I by sine R for air and mustard oil is going to be different from air and water. But in any situation, if you try to find out the this ratio between air and mustard oil, it will always remain the same, irrespective of geographical location or any temperature or any other case where the density does not change. If the density changes, then everything else changes. So keeping the density constant means that mustard oil's density will not change, the density of air will not change. If these two densities will remain constant, then based upon, then in any situation, this value sin I by sin R will always remain constant. Okay, if you have not understood, go back and see and listen to what I have said once more. It will be easier for you to understand if you are facing any trouble. Now we have this constant value here. What does this constant value mean? What is this constant value? This constant value is called the refractive index of the medium. You heard it right, it is the refractive index. So what is refractive index? Now you can see from here that okay, refractive index is sin A by sin R. So this is the formula that we use. Now what does basically refractive index mean? What, look into the ratio carefully. What we have here is we have two angles compared, ratio is comparison, right? So we have two angles, incidence and the refracted angles, angle of incidence and angle of refraction in comparison, they are in a ratio. Okay, that gives a value which is always constant for a given pair of medium, and that constant value is called the refractive index. This constant is the refractive index. Now what does this basically mean for a layman, for any person you need to explain, any layman, what is refractive index? Now as I have said that when the ray of light will come from one medium, it will enter another medium, its direction will change, right? It will come, its direction will change. Now how much, by how much will the direction change? What is the ability of a medium to change the direction of light? That is called the refractive index. Okay, the more the refractive index, the more is the ability of a medium to change the direction of light. So basically if anyone asks you what do you actually mean by refractive, not the formula, what is the meaning of refractive index? The refractive index means the ability of a medium to bend light. How much bending they can do to a ray of light is called the refractive index. What is the formula? It is given by sin I by sin R. Okay, now how does this light bend? So as I have said, it depends on the density. So let's look into some situations. So as I said, let's have two medium. Okay, let's not have medium or let's say this is air and this is water. Okay, a ray of light is coming in from air. When it encounters this, it should have moved on like this, but rather it changed its direction like this. Now why did it change towards the normal? See, this was going away, means it was going straight. What has happened, this ray is actually coming close to the perpendicular, right? The ray was going away. This is the perpendicular. The ray was going away, supposed to go away, but rather what happened? It came close to the normal. It came close to the perpendicular. Why did this happen? This happens when ray of light moved from a lighter medium to a denser medium. Now air is lighter than water or less dense than water. So as the ray of light is moved from a less dense medium to a more dense medium, that is water, it will move towards the normal. What happens in the opposite case? Suppose the same diagram, but this time what we do is, this is water and this is air, and ray of light is coming in this direction. It should have moved on like this. Now let us draw the normal. I'm sorry. If this is the normal, the ray of light will move on like this. Now what has happened? It has moved away from the normal. This is the normal. The ray of light should have moved on like this. Rather, it moved away from the normal. Why? Because the density of air is less than that of water. So we have two things now. If a ray of light moves from a lighter medium to a denser medium, the refracted ray will move closer to the normal. Okay, as has happened in this case. Now moving on to the second case, we have here that the ray of light has moved from a denser medium to a lighter medium, and hence it has moved away from the normal, away from the normal. Okay, so if this is the denser medium, the light or ray of light will move close. If this is the lighter medium, the ray of light will move away. So now you know how to draw refracted rays based upon the density of the medium. So this is what we have from this case. Now this is not the only formula for refractive index. There is one more formula for refractive index. Now as I have said, there are always two medium. You need two medium for refraction to take place. In a single medium, refraction will not take place because in a single medium the density remains the same. In air, refraction of light will not take place because air density is same. So once you can change the density, then you can see refractive index. And also keep this in mind, obviously, that for refraction to take place, it must be a transparent medium. It cannot be an opaque medium, because if I tell you that the ray of light is coming and hitting my hand has a different density, but my hand is an opaque object. It is not transparent. You can't see through my hand. So for any transparent medium, for a pair of transparent mediums, this is very important. Okay, so now let us see what is the other formula for refractive index. Now refractive index is denoted by n. Okay, now as I said, suppose there are two medium, medium 1 and medium 2. Medium ray of light is coming from medium 1, it is entering medium 2 and it is bending, suppose. Okay, and this is our normal. Now see, look into this carefully. The ray of light is coming from medium 1, it is entering medium 2. Okay, that means which medium is bending the light? Actually medium 2 is bending the light. Medium 1 is doing nothing. Here ray of light is coming, it is entering medium 2, and medium 2 is responsible for bending of light. So refractive index, if we calculate the refractive index here, obviously we'll calculate the refractive index of medium 2. But with respect to which medium? With respect to medium 1. Because as I said, refractive index is always between a pair of medium, between air and water, between water and oil, between kerosene and mustard oil. So we need at least two medium to calculate the refractive index. So this is refractive index of 2 with respect to 1. Now if you change the medium 1 with something else, then refractive index will also change. Okay, for a given pair of medium is always constant. So that is how we denote the refractive index of two medium. Okay, medium 2 with respect to medium 1. Okay, now what is the formula? This can be expressed with respect to the speed of light. So it is speed of light in medium 1 by speed of light in medium 2. Okay, this is the formula. Refractive index of 2 with respect to 1 is given by speed of light in medium 1 by speed of light in medium 2. If you forget this, remember the first one, medium 2, lies in the denominator. The second one, medium 1, lies in the numerator. So suppose I ask you refractive index of air with respect to water. It will be speed of light in water by speed of light in air. Okay, water will go to the numerator and air, the first one, will go into the denominator. Air means the first one goes into the denominator, the second one goes into the numerator. This is the formula we use for refractive index of a medium with respect to another medium. Clear? Very simple formula. Now this is called relative refractive index. Relative means we are comparing it to something. Now there is another refractive index which is called the absolute refractive index. So what is absolute refractive index? Here, as we are saying, there should be two medium. We are comparing the refractive index of one medium based upon the density of the other medium. Two medias will have, and both will have different densities. Now what if you have a medium which does not have any density? Means there is no particle in that medium. And what sort of medium is that? That is a vacuum. So if you compare the refractive index of any medium which has any density, suppose water, with vacuum. Now vacuum has no density. That's why the refractive index of vacuum is taken as 1 unitary. The ratio, since refractive index is a ratio, so the ratio is 1 because there is no particle, there is no density. So if you compare the refractive index of a medium which has a density with something where there is no density, this sort of comparison is called the absolute refractive index. Means it is not related to any other densities. It is related to unity. Okay. So if we try to find the absolute refractive index, how do we do this? Refractive index. Ri means refractive index. Okay. So absolute refractive index, suppose refractive index of a medium M. Refractive index of a medium M means it is the absolute refractive index of the medium is equal to speed of light in vacuum by speed of light in medium. Okay, numerator vacuum, denominator medium, because obviously this is speed of light, refractive index of medium with respect to vacuum, right? Obviously you don't write vacuum, but with respect to vacuum, so vacuum will be at the top, medium will be at the bottom. This is for absolute refractive index. Clear? Now in your book you may see that in place of vacuum it is written air, refractive speed of light in air by speed of light in the medium. Now why air? You'll have a pink colored box in your book. Take out the page of refractive index and see the pink colored box. You will see the refractive index of air is given as something around 0.0, I mean sorry, not 0. 1.0003. And what is the refractive index of vacuum? As I said you a few minutes back, it is 1. Refractive index of vacuum is 1, refractive index of air is 1.0003. This part is so small that it is almost taken as insignificant. That's why in most of the cases you can use air and vacuum interchangeably. So in some places you can write air, even if you write vacuum in place of air or air in place of vacuum, both are correct because the difference in refractive index is very minute, 0.0003. So since the difference is very small, we can use air or vacuum for absolute refractive index. That is based upon the question. What type of question you will get? If you get with respect to air, then with air. If you get with respect to vacuum, you get with vacuum. And speed of light in air and vacuum are almost same. It is 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second. You all know this. So that is all we have for this video. We have understood what is refractive index, how to calculate refractive index using two formulae. One is sin I by sin R and the other is speed of light in medium 2 by speed of light in medium 1, and this will be the refractive index of medium 1 with respect to medium 2. So all the formulae are given in this video. You have seen in which direction the ray of light will move based upon whether the medium is denser, is highly dense or less dense. So that's all about refractive index. In our next video, we will see how to draw ray diagrams for lenses. So thank you everyone for watching. And until next time, cheers.